Après-midi, je m'appelle Gisela. Je suis travaillé au LS as a PhD student. So apparently, I'm going to give a talk in English. Well, the title of the talk is the thermal evolution of Indo-Pacific warm pore since the last glacial maximum. Well, in this talk, I'm going to provide the new water temperature records from this study region and combine the published data from the nearby cores. I'm going to discuss the upper water structure and heat storage in the IPWP regions. Well, 3 sections in my talk. First, let's have a look at the Indo-Pacific warm pore. This figure shows the region and the position of the Indo-Pacific warm pore. It is defined by the annually average temperature more than 28 degrees. It is the warmest regions in the oceans. So it provides vast water vapor and latent heat to the atmosphere. So it drives the atmosphere circulations like the Asian-Australia monsoon system and La Nina-El Nino oscillations. Well, so you can see here the tropical ocean's influence on climate mostly depends on its huge heat content. So for the past studies, it's important to know the thermal evolutions of the Indo-Pacific warm pore, which could help us to better understand the global climate change. Well, in order to evaluate the thermal evolutions, we have to know 3 factors: the sea surface temperature records, the smokeline water temperature records, and the smokeline depth records. That's because for the oceans, most of the heat stored in the upper water between the surface layer and the smokeline layers. Well, for the previous studies, most of the records are from the surface, and the water temperature records from the smokeline depths are rare. So in this talk, I'm going to show you 2 new records from 2 sediment cores from of the IPWP regions. Well, for reconstructing the past water temperature, we use the magnesium calcium pilothermometers. We select 2 species, 2 planktonic foraminifera species. One is named the rubber, which live in the making water layer, which could give us the information of the surface water properties. And one named the Albaliculata, which live in the upper smokeline. We use it to calculate the smokeline water temperature. Well, for the smokeline depths, we use delta T as the indicator, which is the difference between the surface temperature and the smokeline water temperature. This figure shows the relationship between the delta T and the smokeline depths. When we get deeper smokeline depths, we have a smaller delta T. When we get shallower smokeline depths, we have a bigger delta T. Well, the data discussed in this talk from these 5 sediment cores, 2 cores from this study, 3 cores from the published data. 4 of them located in the Indian Ocean side. 1 is located in the Western Pacific Ocean side. Well, let's move on to the age models. For the 4 of the 5 sediment cores, the age model were built based on the radiocarbon age. And for the one without of the age model, radiocarbon age, I correlate the oxygen isotope to the nearby cores. So the final results show for the oxygen isotope, for all these 5 sediment cores, they varied synchronously within the same range of values. This is guaranteed for the following comparisons for the water temperature records. Well, let's have a look at the sea surface water temperature records. This figure shows the SST from these 5 ocean sediment cores. I also plot 2 lines. One is from the North Greenland ice core, one is from the Antarctic ice cores. They all represent the atmospheric temperature change in the North Pole and the South Pole. We observe that the SST changing patterns in the Indo-Pacific warm pole, which is more similar with the temperature change patterns from the South Pole. And in addition to, at all these ocean sediment sites, we find a similar glacial interglacial cycles with about 3 to 5 degrees increasing from the last glacial maximum to the beginning of the Holocene. And during the Holocene, we found several cores show a decreasing trend in the SST. Well, let's turn to the submarine water temperature depths. Compared to the SST, during the Holocene, submarine water temperature show a more significant decreasing trend in all these 5 sediment cores. And when we plot them together, we find a unique record, submarine water temperature record, which from the core 2166. And we found the submarine water temperature from these positions is about 1 or 2 degrees lower than the other 4 cores. Well, the foraminifera fauna results in this course also show some special features in the termination 1 compared to the termination 2 and termination 3. This is reflected from the Pratigya percent. You could see the maximum Pratigya percent in termination 1 is 10%. Well, the other 2 terminations 28 and 30%. So we think during the termination 1, this location is affected more from the surface, cooling subsurface water mass from the open Indian Oceans. So in the future study, we are going to reconstruct the SST and TWT during the termination 2 and termination 3 to check if we could also see some difference in the water structures as we see it in the abundance of the Pratigya. Let's have a look at the submarine variability. Also, there are some small unique features for each separate sediment cores. We found a promised increasing trend of delta T since the last glacial maximum. The delta T from about 4 degrees to about 8 degrees. So this indicates the submarine keeps showing since the last glacial maximum in the Indo-Pacific warm pole regions. Well, okay. About all the results, we could make a roughly evaluation about ocean heat content during the Holocene. During the Holocene, we see the SST was decreasing. Submarine water temperature was decreasing. However, the submarine depths getting shallower. So all of this suggests a reduction of the ocean heat content in the study regions during the Holocene. Well, at the last, to make a short summary, we found the SST in the Indo-Pacific warm pole at the beginning of the Holocene were at least 3 degrees warmer than during the LGM, with a slightly decreasing trend during the Holocene. Submarine water temperature more significant decreasing trend during the Holocene than the SST. Well, the increasing of delta T during the Holocene indicated the shoaling of submarine. So we found a reduction of ocean heat content in the IPWT during the Holocene. Well, that's all. Thank you.
Thank you, Aloys. Y a-t-il des questions? Just a question about methodology. Yeah. Why did you choose the sites for forums? The sites between 250 and 300. Yes, that's.
It is the same size with calibration equations. Yeah.
This is for the temperature reconstruction.
Yes.
Thank you. Et donc dernière présentation, Christophe.